Today's topic is going to be on isotopes. Now we have been looking at the periodic table and we've seen that we have elements such as copper and we have elements such as silicon, and the atomic numbers are listed and their atomic mass numbers are also listed, but there's always this odd decimal point going on. And that's what we're going to be looking at today as far as why on the periodic table we have those decimal points, even though the atomic mass is the number of protons and neutrons combined. So as we look through the topic today, you're going to learn about isotopes. You're going to be able to answer that question, and we're also going to be able to know more about isotope notation. If you look here at the example I have of lithium, you can see that we have 3 different lithium atoms. And they're drawn out here along with their isotope notations. And if you look at those, what are the differences between each of those 3 lithium atoms? Hopefully you're realizing that the electrons, the red electrons here, are all the same in number. The number of protons are the same for all 3, but the number of neutrons is what is different, which is also accounted for in the different atomic masses for each. Now just a reminder, as you can see on the bottom of the screen here, is that you have an element and you have its symbol, and then you have the mass number is the number of protons plus the number of neutrons, and then the atomic number is just the number of protons. So if we want to figure out the number of neutrons, we can subtract the atomic number from the mass number, or the atomic mass. So as we look at our example with these 3 lithium isotopes, we can define isotopes as being atoms with the same number of protons but different numbers of neutrons. You can think about it as you would a car. Here I just said a sunbeam LE car, sunbeam SE, and sunbeam LXE. And they're each going to be a generic type of car, let's say. But if we look at some of the features that they have, the LE has a CD player, air conditioning, and 4-door. The SE has a CD player and an aux plug-in, air conditioning, and 4-door. And then the LXE has a CD player, aux plug-in, and Bluetooth capabilities, and also air conditioning and 4-door. So the doors, the air conditioning, that's all the same for all 3 of the models, but the difference is how you can stream your music. That's going to be similar to what we're talking about with isotopes. And you have the same protons and electrons to start with, but the neutrons will be different. Here's an example with carbon, and we have 3 different isotopes of carbon. And as you look at these, consider what is the same and what is different between these 3 isotopes. Hopefully you are realizing that the number of protons is the same for carbon. The number of electrons pictured here in the Bohr's model is also the same, but the number of neutrons is going to be different for each of these. The name of the carbon 12, compared to the carbon 13, compared to the carbon 14, that comes from the atomic mass. So the number of protons and neutrons that it has. If we look here at carbon 14 and we count those all up, we have 1, 2, 3, 4, 5, 6 protons. And then we have 1, 2, 3, 4, 5, 6, 7, 8 neutrons, which gives us a total of 14, hence the name carbon 14. If we compare that to carbon 12, we have 1, 2, 3, 4, 5, 6 protons, and 1, 2, 3, 4, 5, 6 neutrons, for a total of 12 as our atomic mass. So then we got carbon 12 as the name. So that's what isotopes are. Now we're going to look at isotope notation. What are the different parts of the notations, and how do we figure these out? Here you see 2 different examples of an isotope notation, and the different parts we're going to label on this, and then you'll be able to use as well. You have right here the chemical symbol, and that's going to go in the middle. Then on the bottom left is where we're going to write the atomic number. Now remember that the atomic number is the number of protons that a particular atom has. The top left is going to be the atomic mass. So that's going to be your total number of protons and neutrons. And then the top right over here would be any net charge that you have. And as we just learned in our last unit, that charge would come from any electrons being gained or given away. So if we look here at the carbon, you have the carbon, the C for that chemical symbol, 6 is the atomic number, and the 12 is the atomic mass. So let's just practice using those notations and figuring out the numbers of protons, neutrons, and electrons. If we look here at the carbon, the atomic mass and the atomic number are listed. The atomic number right here, the 6, is going to tell us our number of protons. The atomic mass minus the atomic number is going to tell us our number of neutrons. You'll notice there's no decimal points anymore with that. And then to figure out the electrons, we consider if there is any overall charge. Since there's no overall net charge here, then that is assumed a charge of 0. So that would mean that we have the same number of electrons as we do protons. If we look at our example with magnesium, go ahead and see if you can figure this out. Hopefully the answer you found is the same as what we have listed here. Okay, here with this isotope notation, we're going to be working backwards. So here we got the number of protons, neutrons, and electrons, and you want to figure out if you can find the symbol on the periodic table, write the atomic number, which would be the number of protons, add that to the number of neutrons for the atomic mass, and then use the number of electrons to figure out the overall charge. So why don't you go ahead and pause the video, see if you can try these 3, and then go ahead and check your answers when you're done. And here are our answers for those 3, and hopefully you were able to get the same results. If not, make sure that you go back and check some of your work, see if you can find that mistake, and hopefully this video was helpful.